Question 14. 4 identical balls numbered 1, 2, 3 and 4 are in a box. A ball is randomly drawn and it's not replaced. Then a second ball is drawn. So our first question says, what's the probability that the first ball is a 4 and the second ball is a 1? So imagine actually pulling these balls out of the box. It's like lotto. We could draw a tree diagram and say, okay, well the first ball has to be a 4, so the opposite of that is it's not a 4. And then the second ball has to be a 1. So if we get this, we can have a 1 and then not a 1, or we can have a 1 and not a 1 that time. What we want is to get the 4 and then to get the 1. So that's the branch that we want to figure out the probability of. We write the probabilities on the branches, multiply them together. Well, the chance of getting a 4, if there's 4 numbers in there, it's 1 out of 4. Now that the 4's been drawn out, though, we need to think about how many balls are left. There's only 3 left. And how many of them is the one that we want? The 1? Only 1 of them. So we have a 1 out of 3 chance of getting this. So we have 1/4 times 1/3, which gives us 1/12. The other way of thinking it through would be to say, well, there's 12 different outcomes because we could get 4 different things in the beginning, and then there's 3 different things that could happen from that. So there's 12 outcomes and all of them are equally likely. So getting this outcome would be 1 out of 12. That would be fine. Okay, second part. What is the probability that the sum of the 2 balls is 5? Now, the thing that might help you here would be a sample space graph. So for part 2, you might want to think through, what could we get? If we get 1, 2, 3 or 4 with the first draw, and then on the second draw, we could get a 1 or a 2 or a 3 or a 4. Now, there's some possibilities that can't happen. If you've already drawn out a 1, you can't get it the second time. So that can't happen. You can't get a 2 both times because we're not putting the ball back. You can't get a 3 both times, and you can't get a 4 both times. So you'd have to block those out. But you could get a 1 and a 2. That would give you a sum of 3. A 1 and a 3, or a 1 and a 4. That would give a sum of 5. And a 2 and a 1, that's a sum of 3, a 2 and a 3, a 2 and a 4, and then we can add these up and fill in the rest of this chart, and we've got that. So they're all the outcomes that could happen. Now, how many are there? Well, there's not 16 because there's these 4 that can't happen, so there's actually only 12 outcomes that are possible. Now, how many of them give us this sum of 5? This one, this one, this one, and this one. So our answer is 4 out of the 12 things that could happen. And that's a probability of 1/3 once we just simplify that fraction. Now, if you didn't draw a sample space graph, that's fine. You might have just thought through, well, how many ways can I get a sum of 5? I could make 5 by having 1 and 4, or I could get 4 and 1, so that's 2 different things that could happen. Or I could get 2 and 3, or I could get 3 and 2. So that person might just think, well, there's 12 things that could happen, 4 of them give me what I want, and they'd come up with their answer that way. For part 3, given that the sum is 5, so this is a conditional probability question, what is the probability that the second ball was a 1? Now, if you've set up a sample space graph in part 2, it's quite helpful for part 3 because you have all the information in front of you. We know that the sum is 5, so we know that one of these 4 things here must have happened. So how many outcomes are there? For part 3, there's only 4 outcomes that we're interested in. Now, how many of them have the second ball being a 1? Well, if this is the second ball being a 1, only one of them has that. So it's only 1 outcome that's favourable out of the 4 possible outcomes. So that's our answer for part 3, and it's 1/4.